welcome back to the topic on phenols. We were studying the properties of the phenols, in which in the previous videos we have seen so many reactions. Now let us study some special reactions. The next reaction is this named reaction, Kolbe's reaction. Kolbe's reaction. This Kolbe's reaction is actually the reaction of the phenol with the carbon dioxide. When we pass carbon dioxide through the aqueous solution of phenol at about 6 to 7 atmosphere condition, then it will undergo reaction to give rise to, we will write this phenol OH. When you treat this with carbon dioxide under 6 to 7 atmosphere pressure condition, then carbon dioxide will be substituted in the ortho position so that it gives rise to OH and COOH. Actually, the reaction is carried out in sodium hydroxide medium, so it will give rise to first sodium salicylate. This sodium salicylate is then subjected to hydrolysis by adding this HCl in water. It gives rise to salicylic acid, COOH. Salicylic acid. So, conversion of phenol to salicylic acid by passing through this carbon dioxide at 6 to 7 atmosphere followed by acidification is named as the Kolbe's reaction. The next reaction is Reimer-Tieman reaction. Reimer-Tieman reaction. There are two reactions under this Reimer-Tieman reaction. The first one is when we consider this phenol, it is actually with carbon tetrachloride, with chloroform CHCl3 in presence of NaOH. When phenol is treated with chloroform in presence of sodium hydroxide, it will give rise to ONA and CHO. That is, aldehydic group is substituted in the ortho position. This is sodium salt of the salicyl aldehyde. This on hydrolysis by using this HCl, it gives rise to salicyl aldehyde, OH and CHO. This compound is named as the salicyl aldehyde. The second reaction is with carbon tetrachloride and NaOH. When instead of CHCl3, if you use carbon tetrachloride, phenol reacts with the carbon tetrachloride in presence of sodium hydroxide to give rise to a double salt, sodium salt of disodium salt of salicylic acid. This is named as disodium salicylate, because both the OH group as well as COOH group substituted in the ortho position will also compete with the sodium hydroxide. Both will undergo reaction with the sodium hydroxide because both are acidic groups. That's why it gives rise to disodium salicylate. This on acidification by using dilute HCl, it will give rise to salicylic acid, OH and COOH, along with the formation of 2 NaCl molecule. So this is salicylic acid. Salicylic acid. So salicylic acid can be obtained from phenol either by using Kolbe's reaction or by using the Reimer-Tieman reaction. But salicyl aldehyde is obtained only by treating with this phenol with chloroform and sodium hydroxide, that is by using this Reimer-Tieman reaction. The next reaction is with phthalic anhydride. Phthalic anhydride. Phthalic anhydride in presence of concentrated H2SO4. When you take this phenol, actually 2 molar amounts of phenol will undergo reaction with phthalic anhydride. This is C double bond O, O, C double bond O. This is phthalic anhydride. This is phenol. I will write this complete name, phthalic anhydride. Just observe, when heated in presence of concentrated H2SO4, the role of concentrated sulfuric acid is actually dehydrating agent. So it will take hydrogen from 2 molecules of phenol of OH group. Then oxygen atom from this carbon oxygen double bond. 2 hydrogens from 2 OH groups of 2 phenol molecules and 1 oxygen atom from the phthalic anhydride. It will give rise to this phenolphthalein. Probably you are very much familiar about this word phenolphthalein. It is used as an indicator. So here in the para position of this hydrogen from actually para position from 2 phenol molecules, it will undergo dehydration to give rise to this phenolphthalein. Probably you know one important thing regarding this phenolphthalein. When we titrate strong acid versus a strong base, phenolphthalein can be used as an indicator. So this phenolphthalein, when treated with sodium hydroxide, that is alkaline medium, with alkali or in alkaline medium, that phenolphthalein gives rise to pink color. So that's why it is used as an indicator. Original phenolphthalein does not have any color, it is colorless. But when treated with this sodium hydroxide or in the alkaline medium when it is dissolved, it produces the pink color. Imagine we are taking HCl in a conical flask. We are adding sodium hydroxide from the burette. When we add more drop by drop sodium hydroxide, till all HCl molecules are neutralized, the solution will be acidic only. Exactly at the neutralization point when pH is equal to 7, it is actually neither acidic nor basic, it is neutral. But one small drop of extra sodium hydroxide will change the phenolphthalein to the pink color. So this is the reason or theory behind the use of this phenolphthalein as an indicator. In the strong acid, strong base titrations or weak acid, strong base titrations, we can use the phenolphthalein as an indicator. It will undergo some structural changes when we add that sodium hydroxide. That's why it will give rise to the pink color. So these are some important reactions of that phenol. One more reaction is with methyl chloride CS3Cl in presence of anhydrous aluminium chloride. Anhydrous aluminium chloride. Probably you all may be knowing the type of reaction that is taking place. When we take this methyl chloride and anhydrous aluminium chloride, it is a Friedel-Craft's alkylation. Friedel-Craft's alkylation. When we carry out the Friedel-Craft's alkylation, OH group of the phenol is an ortho and para-orienting. That's why when phenol is treated with methyl chloride CS3Cl in presence of anhydrous aluminium chloride, it gives rise to ortho OH and CS3. This is ortho plus OH and CS3 para, and these are nothing but the cresols. I have given the examples of these substituted phenols. If the OH group and the CH3 group are in ortho positions, it is called orthocresol. Similarly, paracresol. Metacresol cannot be obtained by using this reaction because OH group is directly ortho and para oriented. So this is about some of the reactions that we use in, we come across in the phenol topic. The next important property is acidic character. Why phenol is acidic? And what happens if ortho position, para position or meta position contains some electron withdrawing groups or some electron donating groups? That we will see in the next video. Thank you.